George, thanks for joining me today. George is the owner of Packtenna, and George, let's just start with your backstory. How did you get in the antenna business?
Hi, Mike. It's great to be here. Well, it's sort of funny. I did a lot of portable operating and still do. And about 10 years ago or so, as POTA was kind of becoming a big thing, I was doing more portable operating, and I bought a bunch of different antennas, portable antennas, and used them. And what I found was they're all good, but none of them were really as lightweight and small as I wanted. So I wanted to create some kind of an antenna for myself that was just super small and compact, but gave me good performance, especially for QRP radios. And the conclusion I came to was the only way to really do that was with wire antennas. And the problem is really putting the antennas up, except for lobbing it in a tree. It's kind of hard to put up a good wire antenna. And then I found a fiberglass mast that was pretty large. This is just at the time when you started to see more fiberglass and subsequently carbon fiber masks coming onto the market. And so I thought, well, that's kind of the enabler. And so what would I do with that? And so I came up with the notion of a universal feed point that would allow me to build various antennas. And over the years, that morphed from basically a dipole kind of feed point into a line of portable lightweight antennas, a combination of dipoles and end feds and others.
Awesome. Okay. All right. So if you watch any ham radio channels or on YouTube like I do, you know that it's honestly it feels like the NFET of the week club. And so with that in mind, let's talk about the Pack 10 line and what makes it unique.
Mhm. Yeah, so really the focus for me was not to build yet another antenna. Actually, when we started making NFEDs, I'd say they were popular, but they've gotten very, very popular over the last 7, 8 years. And the thing that I really wanted to focus on was to make the absolutely lightest weight, smallest possible antenna that could still handle 100 watts and be appropriate for field use. And so part of the thinking was not to build it into like a big box and make it heavy and bulky, but to make it pretty streamlined. And part of the design was to not only make it small and handle high power, but also make it very high quality. So we made sure that our manufacturing is done by uh, regular contract manufacturers here in the United States that do large kinds of production runs of electronic systems. And so electrically, ours is relatively simple for what most people do, but there's a lot of hand assembly involved. So we really focused on that kind of lightweight, portable, and also very rugged for the size and weight.
Awesome. Okay. All right. So let's talk about end-fed half wave versus end-fed random wire.
Mhm.
Let's talk about the differences there.
Yeah, so on first blush, they seem to be the same thing. And this question comes up all the time. So, especially new portable operators, they hear a lot about end-fed antennas, and it's very confusing. Like, well, what's the difference and when would I want one or the other? The basic difference between an end-fed half wave and a random wire is that the half wave antenna is a tuned antenna. So it's cut for a very specific length. And that means that you don't need an antenna tuner. You can just plug it into your radio and it'll work just fine without a tuner. So that's great for things like an ICOM 705 or a FT 818, 817. A lot of the radios that don't have tuners built in. The difference between that and a random wire is the random wire antenna, as the name implies, is not a specific tuned length. In fact, random is almost kind of a misnomer. It's really not totally random. It is not resonant. And so that means that you have to have a tuner to bring the antenna into resonance on the band that you're operating. So in that case, you really need something like an Elecraft radio or an outboard tuner like an LDG tuner or some other kind of portable tuner, so that you can make the antenna tuned to 50 ohms, which is what the radio wants to see. So what it kind of boils down to is what bands do you want to operate? How much extra equipment do you want to carry around? And you kind of make these trade-offs. So, like for me personally, I my go-to antenna is the random wire because that lets me easily bop around between different bands. I can go to 40 and 20 and 17, and I just tune it, and it's fine on any of those bands. If I were going backpacking and wanted to minimize the kit of stuff I'm taking, then I would take the infant half wave because you don't need a tuner. So if your radio doesn't have a tuner like a 705, which I love, then the end-fed half-wave is a great antenna for that. So it really boils down to what bands do you want to operate? Do you want to carry a tuner or not? Does your radio have a tuner built in? And that kind of dictates what's the right antenna for you. Performance-wise, they're pretty much the same. Now, some people would say that the end-fed half-wave would be a more efficient antenna because you might lose something in the tuner. But in my experience, that really is not a big deal. The biggest determinant of efficiency is how much of a wavelength is the antenna. So for example, if you have like a 30-foot piece of wire and you're operating on 40 meters, you're only a few feet off from resonance, so it's fine as a random wire antenna. But if you take a shorter piece of wire, let's say 15 feet, and try to operate on 80 meters, the tuner will probably tune it, but it's not going to be terribly efficient. So you kind of have this trade-off of the antenna length versus the frequency band that you're operating.
Very good. Well, all right. So you carry two different antennas right now: the PT-101 and the EFHW 2010. And so let's talk a little bit about those. We'll start with the PT-101, and which is a 9-to-1 antenna, and we'll start there.
Yeah, so if you look at these physically, they look identical. They're the basic design of the antennas you can see here is the white carrier board is what holds everything. There's a matching transformer in the middle. There's a BNC coax connector on the bottom. Up at the top of the antenna, there's an additional banana connector. And at the base, there are two banana connectors. You can't really see it here because it's under the wire. And some of the antennas are just the wire is just cut off, and some of them have loops and additional banana connectors to extend the wire. So if you looked at it from afar, they look the same. The difference is the transformer matching unit that's built into the antenna. And of course, the way we design it, the shape of the body is a wire winder. So that really minimizes the amount of stuff that you need. And then the antenna matching unit is covered in a thick shrink wrap. And the reason we use shrink wrap is it's good from an abrasion point of view, but also it leaves the ends open. And so if you're out of doors and it gets wet, you want it to be able to dry out. And so there's an air gap there that allows you to dry the antenna out very easily. So they look the same from a distance, and the only difference really is the transformer. The 9-to-1 random wire is a 9-to-1 transformer, as the name suggests. And what that really does is it takes a potentially high impedance end-fed random wire and brings it down a ratio of 9-to-1 in impedance. So from a practical point of view, let's say your random wire antenna length gives you somewhere between 2 and 5,000 ohms of impedance. You need to bring that down into the range that a tuner will handle. And a good wide range tuner typically tunes anywhere from about 16 ohms to about 800 ohms. So you need to get that couple thousand ohms, worst case, down to a couple hundred ohms, then the tuner can take it from there, which is why you need the tuner. If your wire happens to be a length so that the transformer brings it down to 50 ohms, you might be lucky and maybe you don't even need a tuner. But to work multiple bands, you'll definitely need the tuner.
Okay, very good. Well, let's talk about feed line, because feed line obviously is the other half of the dipole here, if you will. And
Yeah.
so, what kind of feed line do you recommend with your antennas?
We're kind of lucky on portable HF because there's two things that are going in our favor. First of all, HF is such low frequency that the attenuation of most coax cables is not bad. And being in the field, you're using fairly short pieces of coax. You're using something that's 10, 20, 30 feet long. You're not going to run 100 feet of coax in the field. So the frequency combined with the shorter length means the attenuation is not a big deal. So the big question is really mechanically what's most convenient for you. And if you look at all the standard coax cables we use in amateur radio, they all they all do the same thing. The smaller coax cables have higher loss, but again, at this frequency, it's not super critical. So when you think about the common cables, you're typically thinking about at the lowest end of size, the smallest cable like an RG 316, RG 174. The next step up would be something like an LMR 195 or RG 58. The next step up is RG8X. The next step up is RG213. And they get progressively bigger and lower loss and more cumbersome. So you're not going to take RG213 to the field. So you're really looking at three sizes. either the tiniest stuff, which is RG316 or RG174. That's very small cable. That's like an eighth of an inch, a little bit more than that, or RG58 size coax. Now, for me, it really depends on the setup. And if I'm going to be hiking, my goal is to minimize the weight and the bulk. And the right answer really is RG316. And the reason is it's the smallest cable. And if you compare it to RG174, they're electrically the same. But the RG316 has a Teflon or PTFE dielectric and usually a pretty strong external covering over the coax, where the RG174 in hot weather will actually get very soft. And the internal dielectric can deform under heat. So between the two, I would go RG316 for sure. So if I'm backpacking or on a day hike, or if I'm traveling and I want to minimize the bulk, RG316 is a great coax to use. And we sell several different lengths of that with connectors already on it, with BNC connectors for portable operating. The next step up that I would use would be RG58 or LMR 195. But the only real reason to go to that, it's lower loss, but that's not really the reason. The main reason, it's mechanically more sturdy. So if you're going to the park and you're going to lay out your coax and someone might be walking around and stepping on it or tripping over it, then carrying a piece of coax 50 feet to the picnic table is not a big deal. So I would certainly consider taking that bigger coax. Bigger than that will work, but it's really not necessary. So by the time you get to RG8X and that stuff, to me, I think that's overkill, and I wouldn't bother with that.
So let's talk about the RG316 for a second, because you have a 20-foot length and you also sell a 3-foot length. What's the power handling capability of that?
If you look up the manufacturer specs for RG316, most of them will spec it at a maximum of 400 watts, which is surprising. I mean, you look at this little coax and think 400 watts, no way. I don't think I would put 400 watts through it. But, when we're talking about QRP, we're looking at, 5 or 10 watts. So RG316 will work perfectly fine with a 100-watt radio, no problem at all. It's well within its rated specs.
Okay. So let's talk about your inline choke. When do I need that inline choke? And let's talk a little bit about that.
Yeah, great question. So first of all, what's the problem you're trying to solve? If you have common mode current or RF that's flowing back down the coax to your radio because of a poorly matched antenna, then you may potentially have problems. So what happens is when you're transmitting, the RF energy goes up the coax, gets to the feed point of the antenna, and ideally it's all radiated. That's the perfect world, right? Sadly, we don't always live in the perfect world. So what happens is some of that energy will be reflected back down the coax to your transceiver. Now, depending on how much energy is coming back down the coax and the radio or other equipment that you're using, that may or may not be a problem. So, for example, with an end-fed half wave in particular, since the coax is your counterpoise, or as you said, Mike, the other half of the antenna, since that's the case, there's a good chance there'll be some RF flowing back to the radio. If you're operating a 5-watt QRP radio, the amount of energy that's potentially coming back is so low that it's not going to cause you any problems. But if you have a 100-watt radio and there's a fair bit of current coming back towards you, what could that possibly do? Well, it could potentially damage your transmitter. In my experience, the most common problem is that the radio will see this RF energy and just shut off. So one of my favorite field radios is an FT 891. I love the radio. It's a great 100-watt portable radio at a great price. But if you run that thing at 100 watts, there's a good chance that you're going to get enough RF coming back down the coax that it's going to shut off to protect itself. So to prevent that from happening, you put a choke in the middle of the feed line. So what this does is it allows the RF to go up the coax, but as the reflected energy comes back down, it will be attenuated significantly at the choke, so much so that it effectively eliminates it from the feed line coming back to the radio. So that eliminates it. So the question I get all the time is like, do I need a choke? And the answer is, well, it depends on how much power you're running and to some degree how you set your station up. So my rule of thumb is, in my experience, at 5 or 10 watts and maybe 20 watts, I've rarely seen a case where you need a choke. In fact, never at 10 watts and below in my personal experience. At 100 watts, most likely you're going to need one. The question is, well, what about in between? 30 watts, 50 watts, 75 watts. It really depends on your radio and your setup, and the antenna that you're feeding. So my general rule of thumb is if I ever run more than 10 watts, I always carry a choke just in case I need it. And you could pretty much bet anything that's over 50 watts, you're probably going to need one.
Awesome. Okay. I do want to mention also that we do carry the LMR 195 that you have as well, which is a 25-foot cable.
By the way,
So,
the LMRs, just you brought it up. So
mhm,
sometimes people aren't familiar with the LMR cables. The LMR line of cables are mechanically the same size as the RGs,
mhm.
but they have a foil wrap shield. Sometimes they're double shielded, so they're a higher quality coax for a higher frequency operation, which makes them 50. It's fine at HF. LMR is fine or slightly better, but certainly by the time you get to VHF, then the LMRs are much better.
Absolutely. Okay. All right. So I do want to mention also you have a groups.io support page as well as your Packtenna website, and I'll have links down in the description for that. Is there anything else that we should cover before we go?
Let's see. We do have a couple of other antennas that right now aren't in the DX Engineering store, but hopefully they will be. We also make a dipole. We make some VHF antenna feed points for doing things like 2 meter single sideband, and we're coming out with some other stuff. So we're continuing to grow the product line. I'd say right now, by the way, the most popular antenna that we sell is the end-fed half wave, and I think that's because it's universally usable on any radio, including all the radios without tuners. Even though my favorite is the random wire because I can switch bands so easily. So um, one last thing is a lot of times people say, well, which antenna should I get? And my answer to that is all of them. Now, obviously, the reason I would say all of them is you get to buy more antennas, right? But the fact of the matter is that it really depends on how you operate. And in my experience, having the ability to switch between a half wave that's a random wire or an end-fed half wave that's pre-tuned, or even a dipole, it's nice because when you go to set up, some days you're going to be in the in the woods with nobody around and you can set up anything. And other days you're going to be, at a park with a bunch of people nearby, and your footprint really makes a difference. Sometimes you have a tree, sometimes you don't. I mean, depending on how many different kind of locations you go to and set up, you may have different requirements, like the choke. Do you need a choke? Well, if you have a 100-watt radio, sometimes, yeah, you probably do. So you kind of accumulate the accessories over time, and all of our products are interconnectable. They all use BNC connectors, which is universally used on QRP radios. So all the cables, all the antennas, everything is compatible, the choke and so forth. You just build out your system as you like it.
Awesome. Okay. I did want to mention one other thing too. You had mentioned earlier that there is provisions for a counterpoise on these antennas. Do we need a counterpoise?
Well, that is like the number one question. So let's talk about a dipole. A dipole has, by definition, one of the wire elements is the counterpoise. Really, it's the sort of ground half of the dipole. So a dipole has both elements, and you can see it with an end-fed half wave. The radiating element, the primary driven side of the antenna, the hot side, if you will, is the wire, and the RF is going to go somewhere. And whether you intend for it to go somewhere or not, it's going to find a path. So in an end-fed half wave or end-fed random wire, the coax becomes your counterpoise. And to some degree, it's very important how long your counterpoise is, by the way. So that's an important thought. So you're going to have a counterpoise that's going to be your coax, and that gets back to the conversation about the choke. So since the coax cable is an active part of your antenna system, how long it is, where it's located, the elevation of the feed point off the ground will all affect the tuning of the antenna, and the amount of power will also affect whether or not you have common mode current to mess with your radio. So you do have a counterpoise, whether you know it or not. It's your coax cable. And again, back to the point about the choke, you may need a choke depending on how much energy is coming back towards the radio. So just the last point about the length of the counterpoise, it's not super critical, but my advice is to keep it somewhere in the neighborhood of a quarter wave or so around the lowest band you operate. Again, it doesn't have to be tuned. So for instance, I find that a 20-foot piece of coax is really an ideal size if you're operating 40 meters, 20 meters and up, because it's a little bit short for 40, it's a little bit long for 20, so it's really great. And mechanically, 20 feet is a very convenient length. Now you can go shorter, but your antenna will be kind of slightly less efficient as you go shorter from that quarter wave. So let's say 10 feet on 20 meters, not so bad. 10 feet on 40 meters, not so good. So it's not a binary thing like it won't work. It's just not going to be quite as good. So what I my personal recommendation, if you said, well, what's the perfect kit out, would be a 20-foot piece of cable as your primary feed line, and if you're operating high power, carry a choke, and then maybe a shorter cable, like a 3-foot or 10-foot, from the choke to the radio, and then you've got all your bases covered.
Awesome. Well, George, I really appreciate you joining me today. Thanks so much.
Thanks, Mike. Appreciate it.